So let us now show here the solution to the first problem in your module that I sent you in your portal. So the problem is a factory which has a maximum demand of 175 kilowatts at a power factor of 0.75 lagging is charged at 72 rupees per kVA per annum. If the phase advancing equipment costs 120 rupees per kVAR, find the most economical power factor at which the factory should operate. Interest and depreciation total 10% of the capital investment on the phase advancing equipment. So, you see the point here is, in most cases, we also would want to correct the power factor to unity because that is going to save us a lot of money, as we have shown from our previous lectures. However, that may not seem the most appropriate option in practical application, because we know that we have to pay also for the power factor correction equipment. And if you have to pay for that equipment, you have to take into account also its depreciation and interest rates, so that the moment it reaches its what do you call this one, the moment you have uh consumed it has consumed already its lifespan, you should be able to purchase again that same equipment. And that is where the annual charge of the power factor correcting equipment comes in. And before we dive into the solution, kindly make a correction in the module that I sent you. So in page 5, this must be cosine already at this portion, because the final equation, the final term here, square root of 1 minus y over x squared, should already be the most economical power factor. So it has to have the cosine. Okay. So from the problem, so this is, we basically have just one working equation for this one. The most economical power factor being equal to the square root of 1 minus y over x squared, where y is the charge of the power factor correction equipment per year, given in rupees per kVAR per annum, and x is the charge of the maximum demand per year as well, given rupees per kVA. That was shown in the derivation in your module. So I hope you've read your module already. So looking at the problem, a factory which has a maximum demand of 175, etc., charged at 72 rupees per kVA per annum. So 72, obviously there is now the value of your x. So I wrote here 72 already. So rupees per kVA per annum. Now if we look at the second statement, the phase advancing equipment costs 120 rupees per kVAR. My question is that already the value you're going to substitute for y? Is it? The answer, of course, there is no, because y should be the charge of the power factor correcting equipment per, yes, it's in per kVAR, but in per annum basis as well. So we're not, for y, we're not technically talking of the investment that you shelled out to purchase the equipment. Rather, we're talking of the annual charge, the equivalent annual charge of that equipment. That is the one that you're going to write as a substitute for y. And that's not 120, it's actually at the last statement. Interest and depreciation total 10% of the capital investment. So the capital investment is 120 per kVAR, but the annual charge must be 10% of the 120. So this must be 0.1 times 120, which is obviously 12. And from there, we can now solve for the most economical power factor. So square root of 1 minus y is 12 divided by x is 72 squared. And let me just get my calculator. So 12 over 72. This must give you 0.986. There.